Okay, so for those of you that missed the lesson today, we were talking about how light interacts with electrons. And we have to be able to calculate the wavelength, frequency, and energy of the photons of light that are able to excite electrons and move them to a higher energy level. So we're using three equations in all of these calculations. The first one is the speed of light equation. C represents the speed of light, and it is always this number right here. It's always the same number. So anytime you see the letter C in an equation, you will put 3.00 times 10 to the power of 8 there for C. That is equal to frequency times wavelength. And wavelength must be in meters. That is the only unit for wavelength that you can use in these equations. If we're calculating the energy of the photon of light that's going to excite the electron, energy is equal to Planck's constant, that's this h right here, and it's always going to be this number, 6.63 times 10 to the negative 34th. So E is equal to that number times the frequency of the light. Or we can calculate it using the speed of light over wavelength. So one of the things we have to keep in mind if our wavelength always has to be in meters is that we may be given a value in nanometers. If so, we're going to have to do some dimensional analysis to convert it from nanometers to meters. And on the back of your notes, there's an example where we have to do that. So in this example, the red photon of light has a wavelength of 680 nanometers. What is the frequency of this light? So we've got wavelength, and we're trying to find frequency. So what we have to do is look back at the notes and figure out which of those three equations has both of those variables, wavelength and frequency. And if we look at it, the one that has both is going to be this first one, the speed of light equation. So this is going to be the equation that we use. The speed of light is equal to frequency times wavelength. Okay. Now, the speed of light is easy. Like I said, you're always going to put that same number in, 3 times 10 to the power of 8. Okay? The wavelength, we're going to put this value, but before we can put it in the equation, we have to convert it from nanometers to meters. So we're going to do dimensional analysis. We start with what we've got, 680 nanometers. On the front, we had that conversion. And it said that there's 1 times 10 to the power of 9 nanometers in 1 meter. So if I set it up so that my units cancel out like that, we can convert nanometers to meters. So if I do this math and take the number 680 and divide it by 1 times 10 to the power of 9, keeping in mind that any number in scientific notation like that has to go within a set of parentheses in the calculator, we should end up getting 6.8 times 10 to the power of negative 7. So all we did was convert our wavelength from nanometers to meters. Now it's ready to go in our equation. Now we can put that value in for wavelength. Okay, so we're just going to substitute this value for wavelength. So if I put my numbers in the equation where they're supposed to go, instead of C, I put 3.00 times 10 to the power of 8 is equal to frequency, which we don't know, times wavelength in meters, which we just figured out was 6.8 times 10 to the power of negative 7 meters. Now if we're trying to solve for frequency, then we need to do just a really easy algebraic function here. We're going to have to divide both sides by 6.8 times 10 to the power of negative 7 in order to get frequency by itself. Remember, whatever we do to one side, we have to do to the other. So in the calculator, if I take 3.00 times 10 to the power of 8, put it in parentheses, and divide that by, in parentheses, 6.8 times 10 to the negative 7th, then that's going to give me the frequency of this red light. Okay? Now if we do that in the calculator, we end up with this number right here. Now in our starting amount, we had 2 significant figures. There's no decimal on 680, so only the 6 and the 8 count as significant figures. Since I have 2 significant figures in my given amount, we're going to keep 2 in our answer. And so this answer is going to be 4.4 times 10 to the power of 14. So the E right there means exponent. I have an exponent of 14. So for this one, F equals 4.4 times 10 to the power of 14. And the unit for frequency is going to be hertz, Hz. So this is the answer right here. And the next problem, we have to calculate energy. Okay? So to calculate energy, we have to find an equation with energy, and we have frequency here, so we can use frequency. And if I look at the equations, the one that has both energy and frequency is the second equation. So energy is equal to Planck's constant times frequency. And one more time, anytime I see H, I'm going to put this value in. So I'm going to substitute 6.63 times 10 to the power of negative 34. So the equation is E equals H times F. H is 6.63 times 10 to the power of negative 34. And I'm going to multiply that by F, which we had in the previous problem, 4.4 times 10 to the power of 14. So when I multiply those two numbers in the calculator, this is the value I get. And again, since we had a value with 2 significant figures in it, we're going to keep 2 in our answer. So the energy is equal to 2.9 times 10 to the power of negative 19. So my exponent is negative 19 here. And the unit for energy is always going to be joules. Okay? So you guys had some practice problems that we worked on in class. And I'm going to do a couple of them with you just to kind of show you how it works. So if a wave of red light has a wavelength, so this is the wavelength, this is lambda, and it's in meters already, so I don't have to do any conversion. What is the frequency? Well, one more time, I'm going to look at my sheet and figure out which equation to use. It has to have both wavelength and frequency, so it's going to be that first one, the speed of light. So we're using C equals frequency times wavelength. C is 3.00 times 10 to the power of 8. Wavelength is 6.7 times 10 to the negative 7th. So one more time, we're going to move this over by dividing. So we're going to end up dividing by 6.7 times 10 to the negative 7th. And that'll give us frequency. Okay? Once we have that frequency, we can take that value and multiply it by Planck's constant to get energy. So you need to be able to calculate energy as well. You're going to have several calculations where you have to find energy on your homework that was assigned over the weekend. Anyway, I hope this helps for those of you that missed class today.